Okay, so again, this is part 2 of lesson 9-3. And so if you look at this example 2 here on the bottom of page 673, it gives us a function. And it wants us to find, for this function right here, it wants us to find the x and y intercepts, okay? So let's do that part first, and then we'll deal with the transformation afterwards. So I guess I'll come over here. So what we got here is we have a function. It is f of x equals 1/2 x minus 3. And all we got to do is find the x and y intercepts. That's it. All right, so again, the first thing you got to know is, again, f of x, that's the same thing as y, right? So that's y right there. And let's do the y-intercept first. So if you want to find the y-intercept, that's the place where the graph of this function would cross the y-axis, or where it hits the y-axis. And all you got to do to find that, if you think about it, if you're on the y-axis, the x-coordinate is 0. So all you got to do is just, when you want the y-intercept, remember to plug in x equals 0. All right, so then this thing would be y equals 1/2 times, that's worse. So 1/2 times x is 0, and then minus 3. Well, 1/2 times 0 is 0, so then you just get y equals -3. So that's the y value where the graph crosses the y-axis. Now, if you want to write it down like this, you could write down, you could say x equals 0, y equals 3. So you could write down the point 0, comma, -3. So that's your y-intercept. Well, then, if you got to plug in x equals 0 to get the y-intercept, then you're just going to plug in y equals 0 to get the x-intercept. So for the x-intercept, I think I can fit that right here. Well, again, that's the place where the graph hits the x-axis. Well, the y-coordinate there would be 0. So you're just going to plug in y equals 0. Okay, so you're just going to put 0 in on the left-hand side of this function right here. You're going to make this y value on the left-hand side 0. So that's going to say 0 equals 1/2 x minus 3. Okay? Then we just got to solve that. So we're just going to add 3 on both sides. And that gives us 3 equals 1/2 x. And then to finish solving for x, you could divide both sides by 1/2, or you could just multiply both sides by 2. So multiply the left side by 2 and the right side by 2. And then these 2's will cancel out over here, and you'll just get x equals 6. So that is your x-intercept. And then again, if you want to write it as a point, the x-intercept is 6, or the x-coordinate is 6, and the y-coordinate is 0. So you could just write 6, 0. And there you go. So that's all you had to do for that part. So remember those 2 answers, all right? Now let's see, do I got room down here to finish this one or no? Let's see. Probably not. I'll go over on the other side. Now the other part of this is we need to transform the function. So if you look at this rule right here, you have to watch yesterday's video. They're going to start writing the transformation in function notation. So they have this rule for the transformation right here. So this new function g of x is going to be 3 times f of x. Let's make a little note on that right now. Does anybody remember what transformation is that? If I put a 3 out in front of the function. So think back to when we were doing section like 8-7. If you put a 3 out in front, like let me just write something for an example. So back in section 8-7, we were dealing a lot with like the square root function, right? Well, what kind of transformation was it when we put a 3 out in front, like 3 times that function? Yeah. Actually, it's the vertical stretch. Remember, if it was inside, it was the horizontal compression or stretch, and if it was outside, it was the vertical stretch or compression. Yeah, so if you put a 3 out in front like this, 3 out in front of your function, all you're doing is you are multiplying all the y values by 3. So this is a vertical stretch by a factor of 3, which would make the graph like taller or steeper, okay? So if that number out in front, I don't know if you remember all this, but if the number out in front is greater than 1, it's a vertical stretch. If that number out in front like that is a fraction between 0 and 1, then it's a vertical compression. So this one's definitely a vertical stretch. So let's make a note of that, just so we have that, okay? So let me erase this. But let's make a little note, just because I'm going to bring this back when we finish the second part of this. So that 3 right there, the kind of transformation that is, that's a vertical stretch. So a vertical stretch by a factor of 3. And again, that just makes the y values 3 times as big. All right. We don't really need to do that. I mean, we don't need to know that to do this problem, but we'll come back to it at the end. So let's transform the function here. So what we got to do, let me come over on the other side here, is our function that we had was, I believe it was f of x was equal to 1/2 x minus 3, right? And then the new function that we're getting, our transformation, is g of x is equal to 3 times f of x. Well, that's just going to be 3 times whatever the function f is, which in this case is 1/2 x minus 3. So all you got to do is just really just distribute this 3. All right, so that's going to make our function g of x. Well, we're going to do the 3 times the 1/2 x. That's going to give us 3 over 2x. And then we're going to do the 3 times the negative 3. That's a negative 9. And then we're going to go back and find the x and y intercepts again now on this transform functions. So I think I did what I did last time. I did the y-intercept first, right? So let's do the y-intercept right here. So if we do the y-intercept, again, we're just going to plug in x equals 0. And again, remembering that this left-hand side here, this g of x right here, that's the same thing as y. So then our y-intercept, we're just going to do y equals 3 over 2 times 0 minus 9. Well, 3 over 2 times 0 is 0. 0 minus 9 is negative 9, so we get y equals negative 9. So that means our y-intercept there then is 0, comma, negative 9. All right, well, let's do the x-intercept. So if we do the x-intercept, again, we're going to just plug in y equals 0. So we're going to plug in a 0 on the left-hand side. So that's going to give us 0 equals 3 over 2 times x minus 9. So we're going to add 9 on both sides. It's going to give us 9 equals 3 over 2 times x. And then, I mean, you could multiply both sides by 2 over 3. You could, 3 over 2 is the same thing as 1.5, so you could divide both sides by 1.5. Or you could, maybe I'll do this in 2 steps. I'll multiply, let me see. I will multiply the left side by 2 and the right side by 2. So I'm going to do it in 2 steps. Then these 2's will cancel. And that'll give me 18 equals 3x. Then I'll just divide both sides by 3. And I get x equals 6. So that's my x-intercept. So again, that would be at the point 6, comma 0, right? X is 6 and y is 0. Oh, it turned off. All right, hold on a second. I got to get this screen back on. You guys got to shout out to me when that happens. There you go. How's that? I'll take them. Thank you. All right. So anyways, where I was is I said when x is 6, y is 0. Okay. So that's our x-intercept. Now let's look at the. I mean, that's all you got to do for the problem. For the first function, you find the x and y intercepts. Then you transform the function, and then you find the x and y intercepts again. But I want you to think a little bit here. So let me see if I can get all these on the screen at the same time here. So it's kind of small, but I think you guys can see. So what do you guys notice about, from the original function and the transform function, what do you notice about the x-intercepts? Yeah, they're the same. All right. Well, think about it. What we're doing here is we're stretching, remember, this is really small now, but we're stretching this function vertically. When we stretch the function vertically, you know, we're really kind of acting on the y values. You know what I mean? So that means when you stretch it vertically, it doesn't affect these x-intercepts. 6, 0 for the original function and 6, 0 for the transform functions. So then I told you that this transformation was a vertical stretch by a factor of 3. I told you it would make the y values 3 times as large, right? Well, look at this y-intercept over here. It's at 0, -3. And then after we transformed it, it was at 0, -9. So what do you notice about that? What's that? Yeah, it's 3 times the y value, right? Which is exactly what you'd expect. So if you got really good at this, you could kind of do this first one here, this part, find the x and y intercepts for the original function. And if you really got your transformations down, you could kind of come up with these answers over here for the x and y intercepts of the transform function just by thinking about the transformation itself. So when you stretch it vertically, it did not affect the x-intercept, but it made the y value of the y-intercept 3 times larger. All right? And we're just going to do one more of these, just for practice or whatever, same steps or whatever. Maybe I'll see if I can go a little quicker. So we'll do the example 2, part B, and then that'll be it for today. So let's do that. So I think I got to go to the next page. So it's like a different type of transformation. All right, so here we go with this one. So let's go ahead and find the x and y intercepts real quick for the first function, and then we'll talk about the transformation and do the second part. So for the first function, we got f of x equals x squared minus 4. So let's come over here. And we're going to do f of x equals x squared minus 4. All right, again, f of x is the same thing as y. And then for the y-intercept, I'm not going to write all this out again. We know we're going to plug in x equals 0. So we're going to get y equals 0 squared minus 4. Well, 0 squared is 0. 0 minus 4 is -4, so we get y equals -4. And so our y-intercept is at 0, -4. Then we're going to do the same thing for the, or the opposite thing, I guess I should say, for the x-intercept. We're going to plug in y equals 0. And so now the left-hand side is going to be 0, and that's going to be equal to x squared minus 4. And then we're going to add 4 on both. We got to try to solve for x, so we're going to add 4 on both sides. And that gives us x squared equals 4. So then the question is, how do I solve that? How do I get just x? Yeah, you got to use the square root, right? You want to get rid of that squared on the x. So the opposite of squaring is square rooting. So you have to take the square root of both sides, okay? So you're going to take the square root of this side, and you're going to take the square root of this side. But then whenever you do that, like, let me see if I can write this. Well, you guys should know that the little index in here, when it's a square root, the index of the root here is actually a 2, right? There's a 2 in there. Well, whenever you take the even index root of both sides, like if you take the square root of both sides, or the 4th root of both sides, or the 6th root of both sides, then you've got to put a plus or minus over here on the right-hand side, because you're going to get 2 solutions. Now, if that index was a 3, and you were taking the 3rd root of both sides, or the 5th root of both sides, or the 7th root of both sides, in other words, if you were taking the odd index root of both sides, you don't put the plus or minus in there because there'd only be one solution. But anyways, so to do this then, the square root of x squared, the square and the square root undo each other, and you just get x. And then you've got the positive square root of 4. Well, the square root of 4 is 2. And then you've also got the negative of the square root of 4, so you'd also get x equals negative 2. Which means this function right here would actually hit the x-axis in two different places, okay? So you'd get two x-intercepts. One of them is at 2, 0, and the other one is at negative 2, 0. So then let's transform the function and do the other part, and then that'll be it for today. But before we do that, let's talk a little bit about what is this transformation here. So let me write it over here. So first of all, again, so just so we know, remember f of x was x squared minus 4, right? Thank you. All right, and then the function that we're doing, the transformation, we're going to do g of x, and that's going to be equal to, what was it? It's going to be f of 2x. All right, so then we got to kind of think about what kind of transformation is that? Well, it's not 2 out in front. Like last time we had the 3 was out in front of the function, right? What kind of transformation if it's 2 inside multiplied times the x? Does anybody remember? Yeah, it's a horizontal. So it's a horizontal stretch or compression. And then remember, these are kind of weird because it's opposite of what you had for the vertical stretches or compressions. Like last time, we had a 3 out in front, and that was, if that number was greater than 1, it was a vertical stretch. This time, we've got a number greater than 1 right here. So we got a number greater than 1, but it does the opposite thing. It's actually a horizontal compression. And it's actually by a factor that is the reciprocal of this number right here. So again, the horizontal ones are kind of opposite of the vertical ones. So if that was a number, if that was a fraction between 0 and 1 right there, then it would actually be a horizontal stretch. And it would be by a factor that's the reciprocal of that fraction between 0 and 1. But let's put a note over here, because I don't want it in my way where I'm working right there. But we're going to put a little note like we did last time. So like right here, we're going to put a little note. That's a horizontal compression. And it's by a factor of the reciprocal of 2. Well, it's 2 over 1, so the reciprocal of that would be 1/2. Now, it's kind of confusing on what that actually means. That means that if you looked at a particular x value on this original function and you got a y value there, you'd only need half of that x value to achieve the same y value on the graph of this transformation. So only half of the x value would result in the same y value. But you don't really need to know that to finish the problem. So let's go ahead and finish it, and then we'll talk about how that's related to what this transformation is right here. We'll do the problem assuming we don't know that at this point. So we've got to create this problem, or I should say we got to create this function g of x here that is this transformation of the function f. So when it's inside the parentheses like that, what you do then is you take whatever that is in the parentheses, that's like your input, you take that and you plug it in for x right here. All right, so inside the parentheses, you replace x with 2x. So that means that function now would be 2x squared minus 4. All right, so then what's 2x squared? That means 2x times 2x. Right, squared means something times itself. So how do you simplify that? What's 2x squared? We got 2 times 2, right? I said it's 2x times 2x, so you got 2 times 2, that would be 4. But then you've also got x times x, which would be what? Yep, x squared. So it's 4x squared minus 4. So there's your transformed function. Now we got to go back and find the x and y intercepts, and we're done. So let's see if we can do that. So same thing we did before. We're going to do the y-intercept first, so we'll do y-intercept. So for the y-intercept, we're going to, again, this side is y, right? So for the y-intercept, we're going to plug in x equals 0. So we're going to get y equals 4 times 0 squared minus 4. Well, 0 squared is 0. 4 times 0 is 0. 0 minus 4, so it's y equals negative 4. So that gives us a y-intercept of 0, comma, negative 4. All right, let's do the x-intercept. So for the x-intercept, we would plug in y equals 0. So for the left-hand side, we're going to put in a 0. And that's going to equal 4x squared minus 4. And now we got to solve for x. So we're going to add 4 on both sides. That gives us 4 equals 4x squared. Well, we got to get the x squared by itself here, so we'll divide both sides by 4. That'll give us x squared equals 1. Well, again, we don't want x squared, we want just x, so we got to take the square root of both sides. But remember, when we do that, again, when you take the square root of both sides, you got to put that plus or minus in here because you're going to get 2 solutions. So then we get 2 solutions. They would be x equals, well, the positive square root of 1. The square root of 1 is 1. So we get x equals 1, and we also get x equals the negative of the square root of 1, which would be negative 1. So we get 2 x-intercepts. So they would be at 1, comma, 0, and the other one would be at negative 1, comma, 0. And so that's all you had to do for the problem, okay? You found the y-intercept, and you found the 2 x-intercepts. But now go back and think about the transformation a little bit again, though. So let's see if we can get all 4 of these intercepts, or get the x and y intercepts for both of these up at the same time here. So that's kind of small to be able to see that, but I got them both on the screen. So what do you notice about the y-intercepts? Yeah, they stayed the same. So over here, the original function had a y-intercept of 0, comma, negative 4. This one has a y-intercept of 0, comma, negative 4 after the transformation. But then let's talk about the transformation. It was a horizontal compression by 1/2. So that does not affect the y values because you're squishing the graph horizontally. You're compressing it, right? So if you do that, you're not going to affect those y-intercepts. But you are going to affect the x-intercepts. Well, over here, the x-intercepts were 2, comma, 0 and negative 2, comma, 0. But then up here, when we talked about the transformation, we said it's a horizontal compression by 1/2. And I said it would take half of the x value to result in the same y value, right? And the y value we have for these x-intercepts are 0, right? So what happened to the x values? This was at 2, comma, 0. Now after the transformation, it's at 1, comma, 0. This one was at negative 2, comma, 0 on the original function. And this one, the x-intercept, is now negative 1, comma, 0. So what did you do? What's that? They're half. Yeah, they're half. You just half of the x values, right? So that's what I'm trying to get at, is if you understand the compressions, and I don't want you to jump or I shouldn't say compressions. If you understand the transformations, I don't want you to jump to any conclusions and get the problem wrong. But once you find the x and y intercepts for the original function, if you understand the transformations, then you should be able to make a prediction on what the x and y intercept, well, I can't talk now. If you understand the transformations, then you should be able to make a prediction of what the x and y intercepts will be after you transform the function. Because on this one again, it was a horizontal compression by 1/2. So it takes half of the x value to make the same y value. So half of 2 is 1, and half of negative 2 is negative 1. And that's it for today. So let me write the assignment up on here. It's also on the board over here to my left. So this assignment is on page, it's not really long. So this is on page 676 still. So same page as yesterday. In fact, you could just add it on to yesterday's assignment. But today you're adding on 11 through 14, and also number 16 and number 17.